200 tons is the staggering weight of a single military transport vehicle designed to traverse environments that would consume a standard truck. Why were these machines engineered with such extreme physical dimensions and power? It only looks obvious that a vehicle should be compact for mobility, but in reality, the necessity of transporting nuclear warheads and navigating trackless war zones demands a total defiance of conventional engineering limits. These massive platforms move across swamps and deserts where no regular vehicle could maintain traction or structural integrity. The process of moving these giants is only gaining momentum as they occupy two full highway lanes simultaneously. One can notice how the massive multi-axle chassis distributes the weight of a payload capable of neutralizing entire cities. It gets more complex further on. Because these machines were built for maximum durability, a significant number of these decades-old units remain in active service within modern strategic arsenals. The equipment gradually navigates through terrain that defies standard logistics, utilizing specialized independent suspension systems to keep the frame stable. 10 unique configurations represent the most extreme examples of military transport ever manufactured. Everything only gets more complicated when analyzing the sheer scale of the #1 vehicle, which exceeds the proportions of any other mobile land platform. It is visible how the hydraulic systems and heavy-duty engines work in unison to propel these steel giants forward. 100% of the engineering focus was placed on the single purpose of absolute off-road dominance. The machines continue their deployment across the most hostile environments on the planet, serving as the backbone for heavy strategic transport. This technical evolution concludes the initial overview of heavy military haulers. 24,000 pounds of steel and iron constitute the massive frame of the KrAZ 255B, one of the most rugged military trucks ever conceived by the former Soviet Union. Why did this machine become a symbol of brute strength and mechanical simplicity in the harshest environments on Earth? At first glance, the design appears elementary, yet it was engineered to operate where almost nothing else could survive. This Ukrainian-built vehicle began production in the 1960s and established a reputation for absolute reliability through its lack of complex electronics. The process is only gaining momentum. One can notice how the 14.9-liter V8 diesel engine occupies the vast space beneath the hood, producing 240 horsepower. While that number might seem modest for its size, the engine generates immense torque that allows for incredible towing capabilities. The camera glides along the heavy-duty 6x6 drivetrain and reinforced axles that support the weight of the truck. It is visible how the leaf spring suspension, equipped with dual shock absorbers, maintains traction and stability even when the vehicle is at its maximum capacity. But this is just the beginning. The 5-speed manual transmission handles the stress of towing 40 tons through deep mud or steep mountain paths. It only looks obvious to move such weight, but in reality, the mechanical linkages must endure brutal usage without failure. Everything only gets more complicated when analyzing its physical presence. At a length of 9 meters, the truck possesses an intimidating silhouette that commands attention in any terrain. The cabin remains strictly functional with seating for 2 and only the most essential instruments. Massive tires and wide fenders frame the chassis, emphasizing its purpose-built nature. One can notice the reinforced frame members that allow the machine to navigate narrow trails that would stop modern vehicles in their tracks. The engine sound is loud and metallic, rumbling with raw diesel power that echoes off the surrounding landscape. During the Soviet-Afghan War, the vehicle became legendary for its ability to reach isolated mountain paths. Its simple mechanics allowed soldiers to perform repairs in the field with nothing more than basic tools. The process of maintenance was designed for survival in combat conditions where logistics were often non-existent. It gets more complex further on. Civilian sectors like mining and logging still utilize these trucks across rural Ukraine, Kazakhstan, and Central Asia today. Some reports mention individual units logging hundreds of thousands of kilometers without the need for a major overhaul of the powertrain. This longevity is a testament to the heavy-duty engineering that lacks the failure points of computerized systems. A well-known account from Kazakhstan describes a military convoy trapped for several days in a severe blizzard. When other vehicles were rendered immobile by the snow, only the KrAZ trucks managed to escape under their own power. They did not just save themselves, as they towed damaged and stuck vehicles through the frozen wasteland. This feat of endurance is not the limit of what heavy machinery can achieve. The truck transitions from a military asset to a civilian workhorse without losing its fundamental characteristics. One can notice how the paint wears away on the fenders, revealing the thick steel underneath that resists the elements. The machine finishes its cycle of heavy labor and prepares for the next deployment in the field. This marks the conclusion of the story of a truck built for absolute durability and power. Such engineering leaves the factory and enters a legacy of service that spans decades of operation. 12.7 liters is the displacement of the heavy V8 engine driving the Tatraforce T815-7 through the most challenging environments on the planet. This vehicle represents the peak of Czech military engineering, emerging from the historic workshops of Tatra trucks as a result of decades of mechanical evolution. Engineers developed this machine from its inception to provide extreme durability and modularity for logistics and combat. But this is just the beginning. Why is the engine tone described as deep and refined compared to American or Russian equivalents? The 12.7-liter V8 produces over 440 horsepower with a smooth, powerful resonance. A 14-speed automatic transmission manages this output to balance torque with fuel efficiency. The chassis features a central spine frame with independent swinging half axles, which is a signature trademark of the Tatra brand. It only looks obvious to support a heavy truck, but in reality, this architecture ensures every wheel maintains contact with the ground on uneven surfaces. One can notice how the central tube protects the internal drivetrain components from external damage. Everything only gets more complicated as the configuration changes. Drivetrains vary from 6x6 to 8x8 and even 10x10 arrangements. Fully independent suspension allows the chassis to stabilize while crossing deep snow, loose sand, or thick mud. The equipment gradually adjusts to the terrain using an electronic traction system. This system monitors each axle to distribute torque in real time based on resistance. Transition to the next level. The forward-placed cab has a clean, functional design focused on utility. 5 personnel fit comfortably inside the armored structure, which can be fitted with protection against chemical, biological, radiological, and nuclear threats. Military-grade electronics and accessible controls fill the interior space. The process is only gaining momentum. Transporting light tanks, fuel, bridge units, and artillery pieces are standard tasks for this platform. It is visible how the vehicle maneuvers through Arctic zones and steep mountain ranges where other machines fail. In field tests, the truck conquered 40-degree inclines while carrying its full rated payload without any external assistance. This feat earned the attention of international NATO observers. At first glance, the truck is a simple transporter, but in reality, it serves as a mobile missile launch platform and a command center. Several nations, including India, Israel, and the United Arab Emirates, have evaluated or integrated various versions of this modular design. The rugged build remains a primary factor for its adoption in global defense sectors. The machine concludes its demonstration of power, leaving a trail through the dirt as the engine hums with consistent strength. From here, the focus shifts to Germany to encounter a machine that combines brute force with surgical precision. 680 horsepower is the peak output generated by the MAN-D 2868 12.4-liter V8 diesel engine. Why was such an immense power plant integrated into the chassis of the SX45? At first glance, a standard logistics engine might suffice, but in reality, this high-mobility military truck must maintain precise engineering standards while navigating the most unforgiving combat zones. The vehicle emerged in the early 2000s specifically to align with rigorous NATO requirements, serving the German Army and various allied forces during missions that demand heavy logistical support under harsh environmental conditions. The engine operates with calculated efficiency. 12 speeds characterize the automatic transmission, which distributes torque through an 8x8 all-wheel drive system equipped with essential differential locks for optimal traction. One can notice how the independent suspension, bolstered by reinforced shock absorbers, maintains a level chassis even when the vehicle is traversing jagged boulders or deep ruts. Stable handling remains a constant factor regardless of whether the platform is empty or carrying a full payload of supplies. This technical synergy allows the truck to function as a versatile workhorse, transitioning from the transport of fuel and ammunition to the hauling of heavy artillery pieces, shipping containers, or specialized modular command units. The cab sits high and forward to provide maximum visibility for the crew. Up to 5 soldiers can be accommodated within the interior, which features a dense array of integrated digital controls and specialized communications equipment. One can notice the optional battlefield navigation systems mounted within reach of the operators, while the exterior shell of the cab can be fitted with modular armor plates for protection during active battlefield operations. The design remains clean and strictly functional, prioritizing rapid access to mechanical components over aesthetic flourishes. It gets more complex further on. Air transportability serves as a primary strategic advantage for this specific model. The SX45 is engineered to fit inside the cargo hold of a C-17 Globemaster aircraft without requiring full disassembly, which facilitates rapid insertion into remote theaters of of operation. This capability ensures that the truck can begin its mission almost immediately upon touchdown. It is visible how the vehicle maneuvers during deployment, a trait that was demonstrated during recent NATO joint exercises where the units performed without failure across snow-covered trails, steep muddy slopes, and loose gravel roads. Standardized components significantly reduce the logistical burden on military units. Because the manufacturer utilized parts common across various military branches, the SX-45 maintains a relatively low demand for specialized maintenance. This commonality lowers long-term operational costs and simplifies the supply chain for spare parts during extended deployments. The process of logistical refinement does not end at this stage. A new machine of American origin represents the next level of versatility. This upcoming workhorse is known for adopting multiple functional personalities depending on the specific requirements of the mission. 445 horsepower is the output generated by the massive Detroit diesel 8V92 TA 12-liter V8 engine powering this machine. Why did the Oshkosh HEMTT transition so successfully from specialized military logistics to the most demanding civilian off-road missions? It would seem that a heavy tactical vehicle would be too cumbersome for private expedition use. But in reality, the multifunctional architecture allows it to serve simultaneously as a heavy hauler, a refueling station, and a mobile recovery unit in environments where standard trucks fail. 1,700 Newton-meters of torque allow the 8x8 drivetrain to maintain momentum regardless of the incline. It is visible how the reinforced independent suspension absorbs the impact of jagged rocks and dry riverbeds. The process is only gaining momentum as the vehicle navigates the shifting dunes of the Sahara or the Sinai. 11 tons of payload can be carried directly across broken ground without compromising the chassis. The equipment gradually overcomes sharp vertical obstacles that would stall lesser platforms. One can notice how the automatic transmission shifts under load to minimize the physical strain on the operator during missions spanning hundreds of miles. It only looks obvious that such a rugged machine is limited to the battlefield, but its modular design has made it a primary choice for hardcore overlanders. These trucks have been re-engineered into self-sufficient mobile habitats that have successfully crossed the Namib Desert and the Australian outback. But this is just the beginning of its versatility. The flat front and wide armored silhouette are now frequently seen on major film sets in remote locations. Integrated solar panels and expanded fuel reservoirs allow these expedition rigs to remain isolated for several weeks at a time. The camera glides along the heavy steel frame as it hauls production gear through the deep wilderness of Patagonia. 62 miles per hour is the maximum speed this heavy-duty platform can achieve on level ground. It gets more complex further on as the weight of the cargo increases. Reliability remains the core characteristic of the build during every kilometer of the journey. One can notice the steady rotation of all 8 wheels as they grip unstable surfaces. The HEMTT maintains a consistent pace even when the terrain becomes nearly impassable. Transition to the next level. 10 driven wheels are the defining feature of the next heavy equipment transporter. The Oshkosh M1070A1 HET was engineered specifically for the United States Army to move 70-ton main battle tanks. This massive configuration makes becoming immobilized in the sand nearly impossible. The heavy-duty winch system operates with a low hum to pull disabled vehicles onto the trailer bed. It is visible how the heavy tires distribute the pressure across the desert floor to prevent sinking. The power of the engine remains the primary driver of this mechanical force. The molten flow of logistics continues as the HET prepares for its next heavy lift assignment. This concludes the overview of the primary 8x8 platform. 700 horsepower is the output generated by the Caterpillar C18 diesel engine at the heart of the Oshkosh M1070A1 heavy equipment transporter. Why did the United States Army require the development of such a specific logistical platform? The primary objective was the safe and efficient movement of the M1 Abrams main battle tank across vast distances. But a standard transport vehicle would disintegrate under the weight of modern armor, necessitating a machine built for extreme tactical logistics under the harshest environmental conditions. The engine features 18 liters of displacement and operates with a deep, steady, and smooth acoustic profile that reflects its capability for long long-range hauling under intense pressure. It gets more complex further on. One can notice how the 7-speed automatic transmission is synchronized with an 8x8 drivetrain. This system utilizes an intelligent torque distribution mechanism to ensure that enormous loads do not compromise the vehicle's maneuverability or performance. It is visible how the reinforced suspension, equipped with heavy-duty springs and specialized shocks, allows the truck to negotiate rough, uneven terrain without mechanical issue. At first glance, the vehicle's massive scale seems to limit its mobility, but in reality, it can reach speeds of up to 72 kilometers per hour, which is approximately 45 miles per hour. 10 meters is the total length of this rugged transporter. The cab is designed to sit high above the chassis, often featuring optional armor plating and massive wheels that dwarf standard industrial equipment. Inside the cabin, space is provided for up to 6 personnel. The environment is regulated by high-capacity air conditioning and advanced filtration systems designed for operation in contaminated zones. It even incorporates protection against light blasts to ensure the safety of the crew. Everything only gets more complicated during deployment, as the truck is tasked with hauling not only tanks, but also armored vehicles and complex missile systems. The M1070A1 played a crucial role in operations across Iraq and Afghanistan. It moved Abrams tanks through both urban corridors and open desert terrain, a process that prevented excessive wear on the tracks of the armored vehicles. This reliability also minimized mission downtime during long-distance logistics hauls. 130 tons of total weight were successfully hauled by a single M1070A1 during a military exercise in the Arizona desert. The truck transported 2 M1 Abrams tanks in a convoy, maintaining mechanical stability throughout the entire operation. Dust slowly settles behind the tires as the vehicle climbs without overheating, a technical feat that few trucks in the world can replicate. The drivetrain and engine cooling systems were monitored ceaselessly to ensure the massive load reached its destination safely. From here, the transformation of military logistics continues as the heavy equipment transporter moves to its next deployment. 525 horsepower is the output generated by the massive 38-liter V12 diesel engine at the heart of the MAZ 537. Why was such an immense power plant necessary for a wheeled vehicle designed in the late 1950s? At first glance, horsepower figures for a military tractor might seem secondary to top speed, but in reality, the enormous torque produced by this engine allowed the machine to tow loads exceeding 50 tons with relative ease across terrain lacking any formal infrastructure. The Soviet Union specifically engineered this legendary heavy military tractor to transport the heaviest assets in its arsenal, including main battle tanks and ballistic missile systems. One can notice how the power is distributed through a multi-speed manual transmission paired with a sophisticated 8x8 drivetrain. This configuration ensures that every one of the 8 wheels maintains traction even in the most unstable soil conditions. Reinforced torsion bar suspension provides the chassis with the structural durability required for survival in extreme environments. Physically, the MAZ 537 resembles a tank disguised as a heavy truck, measuring approximately 9 meters in total length. The compact cab features light armor and provides seating for 2 crew members who operate the controls. It is visible how the wide tires and squared-off body project a sense of pure mechanical aggression rather than aerodynamic elegance. Everything only gets more complicated when the vehicle is placed under a full load. The engine emits a raw metallic roar that intensifies significantly as the internal components struggle against the resistance of a 50-ton trailer. The process is only gaining momentum as the tractor moves through harsh climates, including frozen steppes and arid deserts. It became indispensable for hauling heavy artillery and tanks like the T-55 or T-72 over mountainous terrain, where smaller vehicles would inevitably stall. During the Soviet-Afghan War, the machine earned a reputation for hauling damaged armored vehicles across destroyed roads where all other transport units failed. But this is just the beginning of its operational history. Even decades after its initial introduction, several units remain in active service for specialized civilian roles across Russia and Central Asia. The equipment gradually proved its worth in industrial recovery operations far from the battlefield. In one well-documented incident in a remote region of Siberia, a single MAZ 537 was utilized to pull a derailed locomotive back onto its tracks. The camera glides along the heavy frame and reinforced hitching points that made such a feat of strength possible. While this model provided the raw pulling power necessary for the Cold War era, its successor added further versatility to the platform. The MAZ 537 eventually became a global symbol of Soviet military strength, appearing frequently on parade grounds around the world. Heavy steel components and oversized cooling systems allowed it to function where the atmosphere would destroy standard commercial trucks. Thus, the heavy tractor successfully fulfilled its role as the primary mover for the most massive equipment in the Eastern Bloc. The material legacy of this machine continues as it transitions into the final chapters of its long service life. 525 horsepower is the output generated by the massive 12-cylinder diesel engine at the heart of this machine. Why did the Soviet Union develop such a specialized heavy-duty platform in the 1960s? The Minsk automobile plant designed the vehicle to serve as a mobile foundation for ballistic missiles like the Scud-B, but without a reinforced 8x8 all-wheel drive system, these heavy weapon systems would remain immobile and vulnerable. This mechanical configuration allows the unit to carry loads exceeding 60 tons while maintaining structural stability across broken terrain. The process is only gaining momentum. One can notice the distinctive elongated silhouette of the MAZ 543, a shape that became a standard fixture in Cold War military parades. The chassis measures approximately 13 meters in length and nearly 3 meters in width, occupying a massive footprint on the asphalt. It is visible how the twin-cab design sits far forward on the frame, featuring small, narrow windows that give the vehicle the appearance of a mobile command post. A heavy-duty manual transmission manages the torque, directing power to all 8 wheels simultaneously to ensure constant traction. It only looks obvious that such a giant would be slow, but in reality, the truck reaches speeds of up to 60 kilometers per hour. The engine produces a deep, steady rumble that closely resembles the acoustic signature of a marine diesel engine. Dual shock absorbers and a reinforced suspension system work in tandem to dampen the vibrations of the massive frame. The equipment gradually overcomes obstacles as 8 large tires distribute the total weight evenly over the surface. This allows the truck to maintain forward motion through deep mud, shifting sand, and thick snow without sinking. But this is just the beginning. Beyond its primary role in missile transport, the platform served as a versatile base for mobile radar systems and air defense units. The camera glides along the heavy steel beams of the chassis, which also supported specialized command vehicles and industrial firefighting equipment. This adaptability extended the service life of the machine well into the modern era, with multiple units still operating throughout Eastern Europe today. During rigorous testing in the 1980s, the vehicle reportedly traveled more than 500 kilometers through desert conditions at full load. This feat was accomplished without a single technical stop, proving the endurance of the cooling and filtration systems. Everything only gets more complicated further on. The iconic status of the truck eventually led to its appearance in various films and documentaries, documenting its transition from a secret weapon to a recognizable industrial tool. Its engineering represents a peak in 20th century heavy logistics, where durability was prioritized over complex electronics. These mechanical systems were built to withstand the harshest environments while transporting the heaviest payloads in the inventory. From here, the narrative of heavy transport moves toward even more extreme machines designed as mobile nuclear platforms. The metal and rubber of the MAZ 543 eventually yield their place to engineering that pushes physical limits even further. 8 wheels and an all-wheel drive configuration define the silhouette of the KrAZ 7428, a heavy military tractor widely recognized by the name Rousich. Developed during the 1990s within the borders of Russia, this machine was engineered specifically for the transport of main battle tanks, massive missile systems, and various categories of oversized military hardware across unstable ground. Why was such a specialized heavy hauler necessary for logistics? While standard transport vehicles could manage paved roads, they frequently failed when faced with the task of moving loads exceeding 80 tons through deep mud or steep inclines. The Rousich filled this critical gap by providing a dedicated platform for recovery operations and the strategic repositioning of heavy armor. One can notice how the chassis maintains its posture even under the weight of 80 tons of steel. This stability is the direct result of a leaf spring suspension system integrated with heavy-duty stabilizers. 12 cylinders form the heart of the power plant, a massive diesel engine capable of generating approximately 650 horsepower. This engine is paired with a multi-speed manual transmission designed for maximum endurance and granular control during low-speed maneuvers. The 8x8 all-wheel drive system ensures that torque is distributed distributed evenly to every oversized tire, allowing the vehicle to maintain consistent traction in snow, thick mud, and jagged mountainous terrain. Everything only gets more complicated as the incline increases. The engine sound remains metallic and constant, radiating across open landscapes with a mechanical rhythm that resembles a mobile factory. It only looks obvious that a vehicle of this size would be difficult to maneuver, but in reality, the high-set cab provides the operator with an unobstructed view of the surrounding terrain. Inside the cabin, the environment is strictly functional and devoid of any ergonomic excess. It is equipped with essential traction control switches and analog weight indicators specifically calibrated for heavy haul missions. The primary role of the Rausich involves the recovery of disabled tanks, the towing of intercontinental missile systems, and the transport of heavy artillery to forward combat positions. But this is just the beginning. The capability of the machine was demonstrated during a specific military exercise involving extreme conditions. During this event, a single KrAZ 7428 successfully towed two T-72 tanks simultaneously across a stretch of steep and uneven terrain. No other vehicle in the existing military fleet was capable of completing that specific objective. The raw physical strength of the platform, combined with its mechanical simplicity and operational reliability, establishes the Rausich as a fundamental component of heavy transport logistics. A different machine, engineered for the movement of nuclear missiles under conditions of total secrecy, represents the next level of strategic transport development. This concludes the overview of the heavy tractor's primary role in military logistics. 800 horsepower is the output generated by the massive V12 diesel engine powering the MZKT 7221. This vehicle represents the modern evolution of Soviet-era missile transporters and remains a critical component of current strategic defense infrastructure. Why is such immense power necessary for a single truck? The engine must move a payload exceeding 100 tons across unpaved and unpredictable landscapes. It achieves this through a multi-stage automatic transmission that distributes torque to a complex 16x16 drivetrain. Everything only gets more complicated when considering the sheer scale of the machine. One can notice the 16 wheels rotating in unison, as the 16x16 configuration means every single wheel is driven to maintain traction. Introduced in the early 2000 years and manufactured by MZKT in Belarus, this truck was developed with the specific purpose of transporting the RS-24 Yars intercontinental ballistic missile. This weapon system serves as a cornerstone of the mobile nuclear arsenal. At first glance, the vehicle appears to be an immovable monolith, but in reality, the rear axle steering provides a degree of maneuverability that contradicts its enormous dimensions. The process is only gaining momentum as the vehicle enters remote territory. 22 meters is the approximate length of this colossus, which carries its massive intercontinental missile horizontally within a specialized, sealed launch container. A fully independent suspension system allows the chassis to absorb the shocks of rough, undeveloped terrain while keeping the sensitive cargo stable. One can notice how the cabin, designed to house 3 crew members, is often reinforced with armor plating for protection. The camera glides along the length of the frame, revealing the intricate hydraulic lines and heavy-duty structural beams required to support the weight. It does not end at this stage of technical specifications. A deep, low-frequency engine note resonates through the air as the truck moves, creating a sound that blends effectively into the surrounding environment. This acoustic characteristic is essential for stealth mobility during long-range deployments. Because the MZKT 7221 can keep strategic missiles hidden within deep remote forests, it plays a central role in the nuclear deterrent strategy. Its mobility ensures that detection or targeting by adversaries becomes an extremely difficult task. But this is just the beginning of its operational history. During a documented military drill, one of these units operated for several days within dense wooded terrain without being detected by satellite surveillance. The dust slowly settles behind the tires as the truck maneuvers through the trees, proving it can perform exactly what it was engineered to do. Transition to the next level of engineering extremes. If this level of military logistics seems like the peak of design, the history of Soviet prototypes contains even more radical examples. The equipment moves toward a legacy that surpasses modern standards. One can observe the transition from this functional colossus to the ultimate Soviet prototype known as the MAZ 7907. This was a vehicle so extreme in its design that it appears to belong to the realm of science fiction. It was a real functional machine that existed unlike any other transport system ever built. The journey of heavy missile carriers reaches its most unusual chapter with the introduction of this experimental giant. 28 meters is the total length reached reached by the specialized transport platform known as the MAZ 7907. Why was such a massive frame constructed with 32 individual wheels? It only looks obvious to call it a truck, but in reality, the vehicle functions more like a self-propelled train designed for off-road environments. This Cold War-era machine emerged from the laboratories of the Minsk automobile plant in the 1980s as a response to extreme military requirements. 100 tons is the minimum payload capacity this experimental Soviet giant was engineered to carry across the most difficult terrain on the planet. The primary objective involved the transport of the RT-23 intercontinental ballistic missile, a weapon of immense weight and strategic importance. One can notice how the sheer scale of the chassis dwarfs any conventional military hardware. The process is only gaining momentum as the internal mechanics reveal an even more complex arrangement of power distribution. At first glance, the propulsion system appears standard, but in reality, it utilizes a GTD 1000TF gas turbine engine. This power plant is identical to the one found in the T-80 main battle tank, capable of generating 1000 horsepower. This turbine does not drive the wheels through a traditional gearbox, but instead powers a massive internal electric generator. The resulting energy feeds 36 individual electric motors, providing a dedicated power source for the drivetrain components. The camera glides along the intricate underside where independent hydropneumatic suspension is fitted to every single axle. This allows the 200-ton loaded mass to maintain stability while traversing deep swamps or frozen tundra. It gets more complex further on. Full-time all-wheel drive ensures that torque is distributed to every point of contact with the ground, allowing the vehicle to bypass the need for established roads or railway tracks. Over 4 meters of width give the MAZ 7907 a presence that feels part transport and part mobile fortress. The acoustic profile of the machine is unique, as the gas turbine emits a high-pitched whine, more characteristic of a jet aircraft than a heavy-duty hauler. This engineering allowed the platform to operate in total isolation, moving nuclear assets through dense forests where no other wheeled vehicle could survive. But this is just the beginning of its operational history. The equipment gradually proved its capabilities during field tests, successfully covering more than 100 kilometers through deep mud while carrying its full designated load. This feat was accomplished without any outside assistance, a technical achievement that remains largely unmatched by modern logistical vehicles. Dust slowly settles over the legacy of the project as the collapse of the Soviet Union and the extreme complexity of the 32-wheel system prevented the truck from entering mass production. Everything only gets more complicated when considering the fate of the single completed prototype, which now serves as a stationary museum piece. It stands as a relic from an era when military competition pushed mechanical engineering to the absolute limit of physical possibility. The machine remains a symbol of durability and specialized mission focus, representing a time when the boundaries of terrestrial transport were redefined. The transition to the next level of heavy transport history begins with the preservation of such massive artifacts. The vehicle reached the edge of what was technologically feasible for wheeled platforms during the late 20th century. These machines were built to function in war zones and natural disasters where infrastructure simply does not exist. They serve as physical evidence of the extremes human engineering can reach when mission requirements dictate every design choice. The material remains a testament to a specific period of industrial ambition. Thus, the history of the MAZ 7907 concludes its phase as an active participant in military logistics.